The topic we are going to study today is potential. The topics we need to focus on are potential, potential difference, electric potential due to point charge, potential due to group of charges due to dipole, then potential gradient, potential difference in uniform electric field, equipotential surface, electric potential of dipole and electric field, lastly, electrostatic shielding. The topic we need to study is potential. The definition of potential is work done by an external agent in carrying a unit positive test charge that is plus 1 coulomb from infinity to a point in the electric field. Let us suppose A is the point at infinity and B is the point at in the electric field, and dr is the distance covered. In the work done covering the distance, dr is known as potential. The formula for potential is V is equal to W upon Q, that is work done upon charge. The SI unit of potential is volt or joule per coulomb or JC minus 1. We need to study is electric potential due to point charge. The formula for electric potential due to point charge is V is equal to 1 upon 4 pi epsilon naught, that is represented as K into Q upon R. The important points to note are that electric potential due to point charge is spherically symmetric and V is 0 at infinity. That is, potential is 0 at infinity. The representation of in the graph of V versus 1 upon R is as given. This is when Q is positive, that is, Q is greater than 0. Let me just write it here for you. Q greater than 0. And this is the charge for, this is the graph for negative charge, that is, Q is less than 0. Is potential due to dipole, which is represented as this. The formula is V is equal to 1 upon 4 pi epsilon naught, that is K, represented as K, into P cos theta upon R square. So the formula is Kp cos theta upon R square. At the axial point, it is plus minus Kp upon R square, as cos theta is equal to 1, and at the equatorial axis, it is 0, as it is cos, the theta is 90 degrees, so cos theta is 0. We need to study is potential gradient. The definition of potential gradient is the rate of change of potential with distance in the electric field. That is, gradient V is equal to dV upon dr. The unit is volt upon meter. dV unit is volt and dr unit is meter. So it is dV upon, and the formula of electric field with relation to gradient V is equal to minus dV upon dr is equal to minus of gradient. Topic is difference in uniform electric field, and represented as this. The formula for difference in uniform electric field is VB minus VA is equal to minus mod of E upon D, mod of E into D. That is This can be represented as delta V. So E is equal to delta V into upon D. Along, then the first special case is along the electric field. When it is in the same direction as electric field, then VV minus VA minus VB is equal to ED. And if you do the opposite, that is VB minus VA is equal to minus ED. The second special case is perpendicular to the electric field. Then ED is equal to 0. So is equal to VB. Now, uh, special cases of diagrams of the cases of equipotential surface. The first one is from a unit positive test charge, that is spherical. The second is from plane blocks, that is plane surfaces. Third one is from a the equipotential surface between a positive and a negative. Topic is equipotential surface properties. No work is done in moving a charge over equipotential surface, that is W is equal to 0. The second one is field lines are perpendicular to the equipotential surface and the surface are closer where electric field is stronger, that is BR is inversely proportional to E. The last topic we need to study is electric potential of electric dipole in fields. The formula for which is U is equal to minus PE cos theta, or minus into P dot E, that is the dot product of minus P and E. The first case is when it is perpendicular to the field, that is theta is equal to 90 degree, so it is 0. And then when P is in the direction of E, that is the potential, that is it is in the direction of the electric field, then it is cos 0 degree as it is in the same direction, so it is minus P dot product into E. And when it is in opposing direction to the electric field, then it is cos 180 degree, that is P dot E. The dot is missing, let me just add it for you. Yes, this is the final one.